Hello, this is Professor Snell again. This is an addendum to the video on this HVAC system and duct sizing rough calculator. Um, I realized, first of all, that I was talking about, at the beginning of that video, I was talking about this model and how there's a plugin I wanted to show you for Grasshopper to kind of show you where you might be going, or to make the point that um, we're not going to be making calculations by hand very much in our careers, but we need to understand these things, is all. But I forgot, so I'm just going to throw this in here. I forgot, I think, because I'm trying to go through this quickly because that was already such a long video. I forgot to mention why we have this internal heat gains thing, maybe. I think I forgot. Remember, we're saying that, okay, if it's, so what are we talking about? We're saying, what's the maximum amount of uh, heating or cooling load we're going to need? What's the worst case scenario? So for heating, internal gains, well, let's see how to put this. For heating, if we have the sun coming in the building, which we covered here, that's a gain for heating, so that actually helps us. We have to produce less heat if we're getting it from the sun. Same thing, if we have a lot of people inside and they are putting out 600 BTUs per hour, and we have in a gym 50 people or 100 people, then that's a lot of heat that would actually reduce our heating load. So that's not going to be a peak situation. It's actually going to bring our peak down, right? But for cooling, both of those things could increase our cooling loads, because if we have a bunch of people in a gym putting out 600 BTUs per hour and the sun coming in, that's going to be heat at a time that might be also the peak heating load for the year, July, an hour in July. And so we need to keep track of that for that reason. We need to keep track of the internal heat gains from people. We'd also have to do it for computers and other stuff. Again, this is just very general, trying to make some points here. So that's why this is here, and that's why it adds in to the total cooling load at the end, but not to the heating load. Okay? Now, remember we were talking about this model, and this architectural model that we were using the zones for and again, just a single story version of it, to populate, or as a design, to define the zones for the spreadsheet that we were just playing with. Um, Let me show you this plugin that actually automates what we were just doing. So here I'm in Grasshopper. It was already open, so that's why this is a little script that they wrote at MIT. The people who do Climate Studio, and I've already got it set up, so that's kind of a shame. Let me show you how it works, though. I thought I'd canceled it, but I guess I hadn't. So basically, I have to go through these steps. I have to define my location with here's some climate data like we've always been using, already been using. I have a climate zone. I then identify my thermal zones and my windows, and I can do that easily by, right, I can come over to, I'll turn all this off even, and let me just turn it off. And I select my objects for, let me turn this on. Sorry, let me get this clearer. Turn off green panes. Okay, so I'm going to select these zones and attach them to this this coding module here. If you haven't used Grasshopper before, maybe I should say this. So this is one of the main advantages of Rhino, is that there's this visual coding language that comes along with it called Grasshopper that tons of people use for all sorts of cool things. And Climate Studio is based on it too. It's in the background, and also they have these scripts that we can use in Grasshopper. But again, I don't want to get too much into the details of it. I'm just showing you that I would select from the model the zones for the floor, for the walls, the windows, and I would apply those to where I need to apply them in the Grasshopper script. Do the same thing with the slab, and so that's the thermal zone here, the windows, and the ground. I didn't do any shading. You have to do a few things like you put it somewhere on your computer, and you run the simulation. So now it's running, and in a second we'll see what it came up with. And so now we have this chart here that it is the first output from this, which is comparing four different, and they just chose these. This is a prototype. There'll be more later, I think. A VAV system, a VAV with economizer, which I mentioned to you in the last video, simply means that it can turn off the heating and cooling and just bring in fresh air when the outdoor temperature is in the right range for that. And then we have fan coil units with DOAS, which is dedicated outdoor air system, and VRF with dedicated outdoor air system. VRF is variable refrigerant flow. So this is a hydronic heat pump system or hydronic system where instead of having a variable air volume, we're having a variable refrigerant volume. The DOAS, just think of it as like a roof-mounted single package unit, but it has the ventilation, has two parallel systems, a ventilation system and a heating and cooling system in it. But you don't need to know that. I'm just showing you that there's this chart now that from the model we just showed, the architectural model that we did. Remember with this one in the last video, we did a bunch of variations we iterated it so that we could improve its energy efficiency. And I'm assuming, I don't actually know, that I've just started using this, that this now is using, I mean, I can't imagine what else it would be doing. This is using the settings for the zones that I have in the model. And then so we can actually compare and say, yeah, actually, I think I want to use a VRF with DOS, but there's a bunch of other, that's just for efficiency, right? So we have heating, cooling, lighting, equipment, fan, pump, heat rejection, showing in all these systems how those compare. But we have also a bunch of other variables down here. So we have EUI, which is really important. This is the lowest, but then we have first costs. This is a little higher than these. The air requirements, very small. This is looking pretty good, right? So the point is there's this simulation we can do that's packaged and easy to run. And then we can come in and what this here is, this riser point on roof, we're defining, see this point here? I associated this point with this input here. And now we can adjust, I'm sorry, I'm going to keep moving stuff around. Let me get this in a position with the things on that I think are useful. Okay, now here's our model, our simulation for the sizing. And so then if now I'm here in the Grasshopper script, and I can just change the system. So I can go from the VAV to the dedicated, the fan coil units with DOAS, or the outdoor unit. So that's, has a different set of components between the fan coil units and the outdoor unit, the fan coil units and the VRF with the DOAS. But the point is now we can quickly do what we're doing in my spreadsheet that we just did, but in a much faster way in this model. So we can come in here now and adjust our duct sizing. You couldn't tell because that was the aspect ratio. Anyway, the point is that I can move the ducts around so that they're over the corridors. I can, change my system and do this. Adjust the aspect ratio. So I'm getting, it's the main supply to branch aspect ratio. There's a bunch of other, I can set the length of diffusers, etc. in this model. So things that even a lot more than what I was doing in the spreadsheet that I showed you can be done in this Grasshopper script directly from an architectural model that we've built for other reasons, right? So that's very powerful. We'll probably be using this in 413 next semester and things like this. But I just want to show you that you're not going to be stuck with these spreadsheets. It's, in architecture, we tend to, even this is a fairly technical thing, maybe you wouldn't even be doing this either, but I hope that at NYIT, you're going to come out with a basic set of digital tools that are part of your basic workflow. Just like when you sketch something on a piece of paper, you actually go, oh, let me check the climate data, let me do a quick thermal analysis model. These things are pretty easy once you learn how to do them, and they're very powerful. All right, that's it for the addendum.